So welcome to part 6. Now we are discussing about the anomaly model. So in this part, we will detect unusual or abnormal pattern in our data using machine learning. So if you could see my screen, we are on this anomaly model. Okay, we'll discuss this more in detail. So what this particular script do? So this model help us to identify situation that doesn't look normal. So, for example, we have a very high demand with very low stock, could be an anomaly. This is one of example. Of course, we have many cases that we're gonna see during the testing. So, if you see carefully, the first two lines are the important libraries. So again, we're using the job lib that we have seen already in part 4, where we have explained the forecasting model, and we are using the isolation forest, this particular algorithm to detect the anomaly. Okay, so let's understand few things about the isolation forest. So what is meant by isolation forest? Okay, so this is a very obvious questions you may ask or you will have. So isolation forest is the machine learning algorithm used to detect anomalies in the data. So in a simple word, it find unusual data points. So how does it work? It works by isolating the data points using random split. What does it mean? The anomalies are easier to isolate so they can detect faster. Okay. Of course, there are no labels required for this data to be labeled. Okay. For this isolation forest. So it learns from the patterns on its own and not from the rules that we set. Okay. And if you see, these are the few points about the isolation forest algorithm. You can read it more. I will put the link for this to understand. Of course, there are a lot of algorithms which are similar to isolation forest, but I have used the isolation forest to find the anomaly in our system. Okay, so the next part, if you see here, I'm just training my order stocks and capacity to train this particular model. And as I have explained already, we are using isolation forest to feed the data to machine learning. We are using contamination 5%. So what does it mean? So it is like we are telling to the machine that we have a 5% of anomalies may present in our data. Okay, so in a real time world, this particular contamination is identified by the data engineers or data analysts. Okay, to find the unusual patterns, and then they decide the contamination. So it based on, let's say example, it's like extreme, find the extreme values. Then I think use percentiles is one way, and check the outliners. Okay, so these are few methods from where we can derive the contamination of the system of the data. Okay, so here we are marking 5%. In the entire data we can have anomalies in present system. Okay, and the next part, we are going to train this particular model. Okay, and with the help of joblib.dump, as we seen in earlier, like during the forecasting, we are saving this anomaly using the pkl files under the model folders. You can see here. Okay, this particular models. Then coming back to again my anomaly models. Yeah, so now you can see the data got trained. Okay, so we can reuse it with the help of pkl files. We have seen that in earlier video. Here we are just loading it again for the reusable purpose, and then we are going to detect the anomalies by passing the models order stock and capacity, so that we can see whether we have anomalies present in system or not. Okay, then we have a predict where we have mentioned -1 minus value, there is anomaly, and 1 is for normal. Okay, so we'll see where, while we're doing the testing of this particular anomaly script. Okay, then we'll see we will understand how the output looks like. So we have mentioned clearly there is a boolean values we have given. So when the animal is there, then it's a true. If not, it's a false. Okay, this is how my anomaly models looks like. Don't worry about the script. Anyway, I'm just putting this project on my git. You can easily clone it and can work accordingly on this project, right? Okay. Yeah. So let's test it. Let's going to test this model. So if you see what I have done, for every model I have created the testing file so we can understand how does it looks like. So this is my testing anomaly model file. So now we have seen, uh, we have already trained the data. Okay. Train the machine learning with the help of our data that we have. Now we'll start finding the anomaly in the system. So I have used few use cases, okay, where we can see how the anomaly looks like if we taste it. Okay. So without delay, let me just run the script. So it's like a python testing anomaly.py. If I run the script now, let me just make it a little visible so that you can see the output clearly. So output is getting generated. Yeah. So now if you see, there are six cases that I have picked. Okay. The first one is the balance system, where the input is 120, stock is 300, capacity is 400. Okay. The output says anomaly is false, the score is this much. Okay. So this is the very balanced system. Of course the orders are below stock and capacity. Then we have seen slightly high demand but the safe level, like orders are 180 and capacity of 400, and we have stock of plenty of stock, like 350 stocks are present. Then the case 3 that we have chosen, like okay, we are nearly equivalent to the capacity but slightly above than the stock that we have. Then of course there are the anomalies. The answer is true and the marking is, you can see. Okay. And then we have similarly for case 4, case 5, case 6, where you can clearly see the orders are more than the capacity. Okay. And the stocks are little low. Okay. Which will help us to identify the anomaly in the system. So this is how we can test the anomaly system and find the detect the anomaly that present in our data. Okay. So in the next, we are going to discuss about the inventory. And then after this, once we see all these training models, okay, and their testing once done, then we will club everything together using fast API. Okay. So let's see in the next video. Thank you.